All right, we are learning our third and final method for solving quadratics today, and that is called the quadratic formula. If it sounds impressive, that's because it is. So the benefits of the quadratic formula are that it always works. It can find rational answers and it can find irrational answers. The problem with the quadratic formula is that it's messy and it's so easy to make small mistakes. So when you choose to use it, you have to go really carefully. And if something is like a relatively easy, straightforward, able to be factored, you're usually better off using that method because you're less likely to make a small mistake. Okay, so let's go ahead and do an example. So first of all, we need to know what is the quadratic formula. It is like this big messy equation and you're going to need to try and memorize it the best you can. All right, let's write it down together. All right, so first of all, you have to have an equation where it equals 0, just like zero product property. So when it's written as ax squared plus bx plus c equals 0, the formula for solving for x is x equals negative b plus or minus, see how I write it as like a plus on top and then a minus underneath? This should feel familiar, like when we're undoing a square root. Negative b plus or minus, and then big square root, negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So hopefully you can see, like, this is not clean. This is not pretty. This is like lots and lots of little steps and big numbers and like things get yucky. So if factoring is an option, factoring is still probably your best bet. But this will always work. So if you're stuck on the factoring, you can switch and try this instead. And so now let's practice. We are going to solve 2x squared minus 5x minus 3 equals 0. Let's pretend you've tried to factor this one. You got stuck on the diamond problem. You just couldn't figure it out. You're not sure if it has no solution or if it has irrational solutions or if you just made a mistake somewhere. So you decide to try the quadratic formula. So first, you need to identify what is A, what is B, and what is C. Well, in this case, A is 2, B is negative 5, and C is negative 3. So now we're going to plug it in to the quadratic formula. And we're going to sing to ourselves while we do it. We're going to say x equals negative b, so it'll be a negative 5, plus or minus the square root of b squared, negative 5 squared, minus 4a, which is 2, c all over 2a. So negative b plus or minus b squared minus 4ac all over 2a. Plugging in the correct number for each spot in the formula. All right, now is the moment of truth. How good are you at order of operations? Let's give it a shot. X equals negative 5, that's just a 5, plus or minus the square root of, and now I got to do all this stuff in here. So what can I do first? Well, exponents happens first, so I can do that right off the bat, 25. And then I'm going to do this. So 4 times 2 is 8, times 3 is 24, and then this is minus a negative. So minus negative 24, and then still all over 2 times 2 is 4. So I did a bunch of steps at once. That's okay. Just like be careful about your order of operations, right? So like the things that you're doing first need to be separated enough from each other that they're not interfering with each other. Okay, so then Next step, I'm still going to leave this 5 out here. I'll deal with that at the end. And then square root of 25 minus a negative 24, that's like plus. So square root of 49 over 4. Fantastic. 49, that's a square number. This is amazing. So this means I have x equals 5 plus or minus 7 over 4. Woohoo! That plus or minus is taking care of the fact that the square root of 49 could be either a positive 7 or a negative 7, right? Like what we saw earlier. Okay, so now I need to split it. Split into 5 plus 7 divided by 2 and 5 minus 7 divided by 2. So 5 plus 7 divided by 2 would be 12 over 2. 5 minus 7 would be negative 2 over 2. So that's 6 or negative 1. So my answer is x equals 6 or negative 1. So I want you to think for a minute. When I tried factoring this up here, was it non-factorable? Or did I just mess up? Hopefully we agree that I made a mistake, right? Because these numbers are really nice. This should have been factorable. I just made a mistake on my diamond problem. I also wanted us to have a nice easy one for the first time we did it. So let's do one now where it doesn't turn out so nicely. But it'll still work. Uh-oh. I just realized I changed this 4 to be a 2. What was I doing? What was I doing? I'm crazy. So this should not have been 6. This should have been 3. This shouldn't have been negative 1. This should have been negative 1/2. Oh my goodness. X equals 3 or negative 1/2. I'm not redoing this video. I'm sorry, guys. I'm sorry. This is like a perfect example. It's so easy to make a small mistake in the quadratic formula. Be so careful. So careful. Okay, I'm giving you 2 new ones. I want you to pause. I want you to try and do the quadratic formula for both. Go until you get to a point where you think you're stuck, you're not sure if you're doing the right step, and then come back and play. And I'm going to do both of these ones at the end a little bit quicker than I did last time. Okay, pause, try them for yourself, and then come back. So for the first one, a equals 3, b equals 5, c equals 1. I'll rewrite the whole formula first. So when you put your numbers in, we have x equals negative b plus or minus the square root b squared minus 4ac all over 2a. Now I simplify. X equals negative 5 plus or minus the square root of 25 minus 4 times 3 times 1, that's 12 over 6. So x equals negative 5 plus or minus the square root of 13. That doesn't look very promising, does it? Yikes. Can't take the square root of 13. That's going to be an irrational number. So, I guess I can, but it'll be an irrational number. So x equals negative 5 plus the square root of 13 over 6, or negative 5 minus the square root of 13 over 6, and not 3, 6. So these right here are the exact answers. Just like that. You can just leave them that way. If I asked you to find the decimal approximations, then I would pull out a calculator and I would type this in. So I type in negative 5 plus the square root of 13, I get negative 1.3944, blah, 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 blah. Then I divide it by 6, I get approximately negative 0.232. And then I could do the same thing for the other one. And that time I get, or negative 1.434. Something like that. Those are the decimal approximations. Okay, let's do the next one. We have a equals 1, b equals 4, c equals 10. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So x equals negative 4 plus or minus the square root of 16 minus 40 all over 2, because 2 times 1 is 2. So negative 4 plus or minus the square root 16 minus 40 would be negative 24 divided by 2. And at this point, I have the square root of a negative number. That is going to mean no solution. So this time I can trust this. I mean, unless I made a mistake. But that no solution, that means that this is a floating parabola or a sinking parabola. It's not irrational roots, right? Because I would have found those if there were. This truly means there are no x-intercepts. There is no solution. And that is because you cannot take the square root of a negative number. No square root of negative number. Okay? All right, for your practice problem, I've given you another one. I want you to solve using the quadratic formula. I want you to round your answers to the nearest hundredth. That's your clue. This one's going to end up irrational, and I want you to find the decimal approximation. Good luck. Use a calculator. Use a calculator.